Welcome, everyone. Uh, my name is Kevin Carpenter. I appreciate you coming to my talk. Today, we're going to talk about tooling intuition. Um, if you're, if this is when I originally presented this talk, it was kind of a back to basics talk. So we're going to talk, the kind of a beginning level talk about the different types of tooling that we have in C++, and when we run into bugs, uh, and problems when we're using our tools, what we can do about it. And so, with that, let me get going here. So, this first slide here is not C++. If you're a Python programmer, forgive me, but I started learning Python a couple weeks ago, literally just a couple weeks ago. I've never used it before. I help volunteer C++ now, and one of the things that we do there is if you're in Aspen and you happen to be at the conference, we will you can order lunches and we'll have lunches delivered in. And so when I first started helping volunteer in 2022, it was this kind of cash thing, and we did it by hand. And so last year, we came up with a web form people could order and pay online, and it was cool, but the web form was just kind of wasn't really what we wanted. So um, working with some other friends, they're like, hey, you got to try Python and Flask. And so here we go, and I'm getting my order form together and I'm learning it. I'm still not so sure about self, but that's just me. But then as I was doing this, you know, I went to save an order, and the first time it saved, the second time I got this integrity error. And as you can see from my browser here, and this was just one of them with all the tabs open. I probably had two more as I'm digging through trying to find this. And the reason this is relevant to me is because, and to this talk specifically, is because even though I've been programming for a year or two, um, picking up a new language, it's like there's yeah, we understand the algorithms, but you still have to build that intuition of what is wrong. And sometimes when you're learning something new and you see a wall of text, as we will see, um, it can be intimidating. And so that is a bit of what this talk is about, is trying to build that part of intuition. How do we go from the problems we run into while we're developing every day, to how to get past them. And so when I first was putting the talk together, of course, you have to Google the word intuition. And so, intuition is the ability to understand something immediately without need for conscious reasoning. And I like that, I marked the word reasoning there because we reason about code, and we'll look at that in a few. A thing that one knows or considers likely from instinctive feeling rather than conscious reasoning, and kind of similar. So, of course, Google ended up showing this little graph, and I was struggling with the topic and all of that. And so I don't know if any of you as programmers have ran into that, but sometimes when you're struggling with something, it's like, ooh, something shiny. So I kind of squirreled on that graph and clicked on it. And I had never seen Google Books Ngram Viewer, but then I saw this graph and I'm like, oh, this is kind of interesting. All the counts and use of the word intuition from the 1800s going forward. And, as I was just kind of eyeing it, I'm like, well, we got some peaks here. Obviously, you know, intuition is being used a lot more now, but I was like, well, let's look at this first one. This is 1877, thereabouts. So I Google intuition for 1877, and Henry Day. Intuition is that function of the intelligence by which an object presented by the mind itself is apprehended. It's not a bad definition of intuition. I mean, it is coming from elements of psychology, as you can see from the first entry there. And so, I'm like, okay, well, that's 1877. I'm like, I'll go back and look at the graph and see what else I find. And, there's multiple points, but I'm like, I wonder if we go back really, that was 1877. I'm like, I wonder what was back here. When did intuition really kind of start? I was curious. So turns out Immanuel Kant, and I may have pronounced that wrong, a German philosopher. And so if you read that definition, the mere form of intuition without substance is in itself no object, but merely formal condition of an object as phenomena, as pure space and pure time. The critique of pure reason. So this is a deeper term of intuition than I wanted to consider. I'm trying to build intuition for solving problems in code, not, it would be an interesting philosophy book. And I got lost reading it a little bit. He had this other quote that, thoughts without concepts are void, intuition without concepts are blind. And again, it reminded me of Socrates and things along that level. And for the time, it makes sense. He did have this quote, though, which I kind of liked, which was rules for happiness: something to do, someone to love, and something to hope for. Something to do, write code; someone to love, that's always a good thing. Something to hope for, no bugs, right? So either way, that was a good quote. So 1787, that's a nice early setup. We come back, and this next peak was, 1967. I'm hoping that we're getting, we had computers somewhat then. So Google Intuition 1967. The major role of intuition is to provide a conceptual foundation that suggests the direction which new research should take. And that was Raymond L. Wilder. And so I followed in on this more. And Raymond L. Wilder, he's a researcher and mathematician, but the role of intuition in research is to provide the educated guess, which may prove to be true or false. But in either case, progress cannot be made without it, and even a false guess may lead to progress. This is kind of more of what I think we get at when we're working as developers, because even when we get, whatever the compiler spits back at us, or a runtime error or a bug, we start to make hypotheses. Now, if it's something we've seen before, then that's kind of where we might have intuition about it, and that'll lead us down a path. And then, as he says, if it's right, then great. But if it's wrong, it still leads us along the path of progress. He also said intuition, as used by modern mathematicians, means an accumulation of attitudes, including beliefs and opinions derived from experience, both individual and cultural. The cultural part and whatnot, I don't know how to apply that. But the point of the attitudes are the things that are derived from experience. I think that is directly what we're talking more about. And so, being that he was a mathematician, that reminded me of a talk that I went to. I want to say it was cpponline, maybe 2016. I tried to find it, but I was unable to. But the speaker was looking at methods as from a mathematical point of view. And so, if you look at this contrived example, by name, of course, it's bytes. If you're familiar with bytes and what we're looking at here, you might already know what the possible values of an int will be, what the possible return values, the amount of combinations. If not, you're going to go, well, mathematically, A can be up to 256 options, B can be up to 256 options. And so the variation of possible return values is 65,536. But what I just did there was reasoning about the code, right? That's not actually intuition. The intuition part is if you'd already had that sense of, well, a byte times a byte, I've done that before, that would be this, then you would have had a kind of a feeling, oh, this is probably going to be somewhere in the realm of a short, or however in that sense. So that was helpful. But then I'm like, you got to look at the top peak, right? You got to look at where we were now. So 2019 and intuition was evidently a great year for wine. Maybe celebrate after you figure out the bugs, but I don't think that helps us with the coding. So, but intuition had a great year in 2019, evidently. All right, so our key points: intuition is that function of intelligence. Intuitionism is the epistemological view that some moral truths can be known with logical inference. I think you can guess where I kind of got that one from. More to the point of R.L. Wilder, the role of intuition in research is to provide the educated guess, which may prove to be true or false, which I think that is, what we're going for. And of course, rules for happiness. I like rules for happiness. I can do those. So when I was starting to talk, I asked a lot of my colleagues, hey, can you send me screenshots of your development environments? And so, we have a bunch of them here. And I just wanted to put the collage together to throw them in. But, kind of the point is that when it comes to our development environments, we have a lot of different interfaces. multiple OSs. Some people are on Windows, some people are on Mac, Linux. I myself am more Linux and Mac, but I do a little Windows. Um, but we got a lot of common tools. I mean, there aren't that many compilers that we really use, as we'll see. And, of course, with that, we all have lots of problems. Hence why we're here, hopefully trying to figure them out. Yeah. Um, and so, looking at the interfaces, we had CLion, Visual Studio Code, Visual Studio, of course, Embarcadero, C++, which used to be C++ Builder. And I know that because that was one of my first C++ compilers, not my very first, but one of them. NeoVim, which I have to thank Tim for, Tim Vendors, and he liked his NeoVim. Xcode. I didn't have code blocks in there, but we also have Qt and Eclipse, so lots of different interfaces. I've seen them used everywhere from Bloomberg, etc. When it comes to compilers, that's a little bit smaller. I haven't personally used the Intel compiler, but all the rest of these I have. We have Clang, Microsoft's compiler with Visual Studio, Embarcadero, which unfortunately I've still used, and technically Embarcadero now is Clang. I want to say it's Clang 5. Someone had corrected me, but the one thing about the Embarcadero is that they don't use the open source STL. So just saying, if they could catch up with that, it would make things nicer. But I'm digressing a little. And of course, GCC. And so I have one or two screenshots. For all you Windows developers, the code examples that I provide are, I think everything is relevant to Windows, and I make some points of options you want to set on Windows. But I will be doing more just code from and comparing the compilers of GCC and Clang, just so we're upfront about it. But all of this still, I think, applies to the fact of the goal of what we're trying to do is build intuition. And so, in helping to do that, static analyzers they've come a long way. I remember starting to use Microsoft Static Analyzer back in Visual Studio 2015. I want to say was the first time I got a chance, but we have Clang or Clang Tidy. Well, it's Clang Tidy, but I say Clang D as well because, you can integrate Clang D into Visual Studio Code and other things, and that kind of gives you Clang Tidy in an instant. PVS Studio, which I've used before. I'm going to say Reshaper, plus plus, if I'm saying that right. CPP Check, of course, which has been around a long time, and Sonar Source. But if you look here at analysistools.dev, I selected C++ only, and they show over 106 tools. I did not go through them all. I just kind of listed the big ones here. But the main thing is we have a lot of analysis tools, and how well do you use them? Are they doing all they can for you? And I think that's going to be the core of what we start getting at as we go through things here. So for me, at least, and I'm hoping for you, when I'm working on code, I kind of come across three types of problems, at least, but we'll focus on these three. You have your compile time, your link time, and your runtime. And so, on the compile time, syntax errors, things that violate the standard, or that's not implemented in the compiler, templates, wall of text, hence my smiley face. Link time, missing libraries or versioning issues, and runtime, of course. And runtime errors are their own, but you also have your logical, your semantic errors. And so we're going to go through and look at some examples of these, as well as how we can use our tools to better assist us. So my very first C compiler was Turbo C++. I was actually using version 2, I want to say. And I have to say that you'll notice that this does say welcome to meeting C++. So it took me a bit the first time I put this talk together to set up Turbo C and do this compile. So I took screenshots. I did not redo this. My apologies. But the thing I want to point out is we got this function here, which is an int add, right? And you see that I've got the cursor over the semicolon there. And in this screen, it compiles just fine. But if I remove that semicolon, not only am I missing the return statement is missing the semicolon on line 4, but you see the laundry list of other errors that are there. declaration is not allowed, another missing semicolon supposedly, and you'll notice that scroll bar goes down. And so when I was learning to program, this was a thing. Like, you would get a wall of errors if you got a missing semicolon, and in this case, this project was one file. If you actually had something that was even 20 files and you missed a semicolon, some header, hours. I just felt like I spent hours sometimes looking for that one character off. And when you're starting out coding, I don't know, for me, that was like daunting. It's like, um, but fortunately, and so just to show, it did compile and run fine. So that was code in the 90s. Fortunately, we've come forward a few years. Fortunately now, if we take that same kind of a problem here, and I want you to know that I used everything from Compiler Explorer, so this should all be accurate. I just tried to paste things in a lot of cases, so that we could get some better font views. That doesn't always work with PowerPoint, as we'll learn. I had some intuition with PowerPoint over the past few days, but I'll reach that later. But in this case, the semicolon is missing, right? And so it says that we need a semicolon before the return statement. Okay, well, that's a lot better. That's one error. Perfect. And it even tells us the line where it wants the semicolon at 5.5. So I put the semicolon right there, right? I mean, that's where it wants it. That's where the compiler, GCC 4.6 is saying to put it. So it works. I mean, not going to lie, the compiler doesn't care. At least that one doesn't. But what happens if we actually turn around and use Clang? And now notice this is Clang 3.3. It's still an old version of Clang. And Clang actually points out, hey, this is where you want to put that semicolon. And so I always had GCC more. It wasn't until the current position that I'm at that we started using Clang more. And then I really started researching and understanding that, Clang has always, from my understanding, been really good with tooling, like being able to give you back solid feedback of what's going on. And in the recent years, Clang has gotten even better with your binaries being as efficient. As far as I recall from people I've talked to, early Clang GCC provided a faster binary in compiling, but later Clang and GCC, they're running kind of neck and neck. And I just want to say, I see the question that popped up. I'm going to keep focused on this, but I'll be happy to answer stuff and gather town. I'll definitely come hang out. And it's not that I don't want to answer your question. First time, I've done these talks live before, first time doing it online, and my intuition tells me that if I start clicking on stuff, this could all go sideways. So bear with me. All right. So what happens if we take that same thing and go with Clang 17, right? Clang 17 actually gets us even a little bit better, so nicely formatted output, one error generated. And if we take, GCC on its trunk, GCC is, likewise gotten better. And I would say that's kind of the theme here, that Clang and GCC and the most recent version of the compilers are definitely, they're running neck and neck, and they both have great output now. So the point here, use a modern compiler. Definitely not something from the 90s if you can absolutely avoid it. We do use Embarcadero at my current company. And so, Clang 5 works fine in there, but, use a modern compiler. And if you can't use one compiler, if you're stuck on an old compiler, then use two. And that was my point of showing that even older Clang, gives you great feedback. And so if you're stuck, happen to use GCC, see if you can't pull Clang into the mix too. And I do want to say, I believe that it was Visual Studio 2015 was when it might have been before that, but I'm pretty sure 2015 had the integration with Clang starting back then too. All right, so let's move on to some more errors, compile time errors, right? More, but this time based on standards. So this is, I think Jason called it convoluted hello world. Jason Turner, I picked this up from watching one of his videos. We're using a Lambda, we're taking Clang 3.7. Of course, if we try to compile this, it expected an expression. And why is that? Because Clang 3.7, we're not telling it which standard C++ we're using. And at this point, it was not handling lambdas. If we turn around and add the standard being C++ 14, well, welcome to C++ Online UK 2024. It works great. So when you're using an old compiler, you want to make sure that if you're writing code for a specific standard, make sure that you're having that set. And I think that that can be useful from 2 points. You know, a lot of our compilers are, of course, up to snuff for 14 if you're using a reasonably modern one. But this way you can be very direct that, look, I'm trying to use a C++ 20 feature. Not all compilers implement every feature. And so this way you can be sure that if it's available, you are trying to let the compiler know and give it that hint that you're going to be passing it stuff it should expect. So again, use a modern compiler. So for compile time, we'll call syntax errors good for the moment. And we'll move on to, well, I say everyone's favorites. I've actually gotten better with templates, but do you love templates? I used to not. It used to be one of those things where even some of the people I worked with, it's like, you don't put template code in. Because nobody loves template errors. At least I don't. So, simple example here that we have, a vector of ints v. We just want to do a find on it. We're looking for a specific integer in the vector. I did get this example from, I want to say, Stack Overflow. I said, hey, give me an example that is small that gives me a lot of noise. And so for the sake of the video, you'll notice that this is actually running off the slide, and it kept running for a while, but I think everybody's seen a wall of text before. So I think the point gets made. Template errors are generally not fun. And it reminds me, kind of going back to that part with the Python where, Python, I've done lots of programming languages. I program in Go, I've done JavaScript, C++, and I've forgotten languages, Perl, PHP. But when you're starting something new, at least for me, I have that intimidation factor. I'm like, oh no, and then if you have a deadline to go with it, you're like, I got to get this done. And now I'm stuck with this. What am I going to do? So if we take a newer version of Clang, though, it at least gets us a little bit better, right? Okay, there we go. It's not a wall of text. It fits on the slide at least. So there's an invalid operand to the binary expression, but line 270, I certainly don't have 270 lines in there. And so there again, if you're still new trying to figure out types and how types go in together, this could be better, right? It would be better if we could get some more detail on it. And so do you W all? Do you use all your compiler options and turn on all your warnings? With template errors, you definitely should. Because if we use W all, you'll notice that we actually, using the same Clang, we actually get some decent feedback. Variable A is an uninitialized when passed as a const reference argument here. And so now we actually have good feedback. And so, as we've been talking about these slides and going through them, the thing I want to point out is, again, the point of the talk is how do we build intuition? And to me, especially when we're learning something new, coding is hard. And I think that the fact that as we solve problems like this, it buys you that little bit more into, I consider it like working out or something. It's like it's tough mentally, but then once you get it, it adds that little bit so that next time it just adds a little more. And to that parameter example with mathematics that I showed earlier, sooner or later you're going, oh, a byte and a byte. Yeah, it's probably about 65,000 or somewhere in that range for the return value. It just becomes, it's not necessarily just reasoned about. You just kind of get that feeling this is what it is. So if I set that to a vector int of A, the program compiles. Actually, it was saying it needed a constant. So if I used a constant A, it would also compile clean. I figured that out, after I made the original slide, hence the pass in. So I do need to say, when I was given the talk before, Daniel Evers, who had come to see the talk, he'd recommended Vittorio Romeo. I hope I'm saying his name right. Chemomelia is a Python script that they wrote that you can actually pass in a wall of text and it'll help trim it down for you. So as you can see there, it takes 38K and runs it down to 36 or to 3.6K. So definitely helps reduce the size. Um, so I wanted to thank Daniel for that and add it because I haven't used it personally, but definitely something to check out. What I did think was funny was when the talk, "What does it take to implement a standard library?" was going on. I saw Ben Dean post this in Discord, and thank you, Ben. He approved me using this. A good newbie tip for dealing with the wall of text diagnostic is to look at the top and the bottom. That's usually tell you what's actually went wrong in the depths, as well as what the top level could have costed. Then all you have to do is understand two things. And I think this is perfect. This is, it took me a while to learn this, but when you do have the wall of text, that is an excellent way to start. Just go to the top and go to the bottom because, even when just working at the standard library, if you pass in the wrong type on a predicate or something like that, it it can go deep. And I do a lot with Enloman's JSON library, and sometimes even there, I've gotten pretty good. But if I pass something in wrong, I I could probably scroll for 60, 70K too. All right. So everyone should W all, W extra, and pedantic. Um, Pedantic, I use it occasionally. I've been told that that's used a lot if you're doing cross compiling, which I only do a little bit of. But GCC has good documentation on it. The link's right there. Clang, fortunately, when it comes to a lot of these things, follows right along with GCC when it comes to command line options. So it can double up for you for both. So compiler warnings and options, live them, know them, love them. Good. And in fact, I'm going to give Jason Turner a couple call outs in this because he really does some great stuff. So he has a CPP best practices, and you definitely want to go check that out. He talks about the options, some of the best ones to use, and it really helps point out what's noise and what's not. And especially when we're first learning the program or when you're starting out. And to me, um, I just picked up a new language, so I'm still just starting out again. You want to get as many details as you can to help out, but then you also want to try to trim the noise a little bit because I've seen some Windows output, nothing against the MSVC compiler, but I put a few things into Compiler Explorer to try to do compiles, and Compiler Explorer may not be an exact a good match. But even when I'm using Visual Studio for an application I worked on, you could definitely get some definite noise. So last year at CPP on C, Bryce had given a talk, AI Assisted Engineering. I like to say Bryce is pointing to the future here. I did hijack that picture. I think it was actually asking to dim the lights, but I thought it was a good picture of Bryce. So his talk was really good. And he talks about using AI to be able to help out with walls of text, and not just walls of text, but errors in general. And so him, Emery Berger, and some other colleagues, they created CY. You definitely want to check that out. It is not just for C++. It actually works for all kinds of languages. I did not try it with my Python error yet, but now I'm going to maybe have to do that. But I'll get back to the Python error in a little bit. Not that that's not, I know C++, but so that's templates, so there's some ways to help work with our template errors. Use a modern compiler, turn on all of your options so that you can get good feedback out of it. Camellia or Ben Dean's option 2. I like Ben Dean's just because it's something that's just right there for me. So I'm always going to try that first. And otherwise, I'll definitely use a tool. I have had some luck sometimes taking a copy and a paste of a specific line, like my first line or my last line for Google, and trying to get some info that way. But, in the end, we're just doing whatever we can to get past this bug because we probably got a couple more. At least I do. I probably have a couple more that I will run into as I go down the list. So, we get all the information we can so we can build on it. So let me grab with that in mind, let's move on to link time. Now, link time errors for me, these can be problematic, but I don't think they're quite as problematic. So linker errors are you've done your compiling, and the compiler is now trying to pull together all your object files or your libraries if you're using external libraries. And generally, they come down to, undefined references or can't find a symbol, a missing library, or I put versioning issues. But really, to me, versioning issues is still kind of a can't find a symbol. And, my experience in that comes to OpenSSL, which I'll probably revisit here. But from a linker error with an undefined reference, so you will notice this code layout is a little bit different. I do hope that everybody can see it okay. This is where I was saying that I need to have better intuition about my presentation software. PowerPoint, I learned, does not like certain fonts, and if you embed them or don't embed them. And so, anyways, that'll be a different talk for a different conference, but I hope you can see that okay. But in this case, you'll notice line 3, int main. Main is capitalized. And so when we turn around and try to run the compiler on that, of course, we're getting an undefined reference to main, because why? It can't find the reference to what it's looking for. It's looking for a main. And this is a very simplified example of pretty much what most linker errors are, is trying to link your object files together, and it's looking either for a reference to a function that you have, or, in this case, all apps C++ look for main as their entry point. And so we get a link failure. This is a bit more of a contrived example. We have a structure A, which has a virtual structure defined that is a pure virtual, right? And then we're inheriting that, or we have what is a struct B, which A is its parent. You'll notice we have an extern int of X, and void foo is a forward declaration. And then in main, we're going to turn around and, assign X0, try to execute foo, and try to instantiate B. This compiles just fine, right? It actually does. There's no errors in that code. However, when you try to link it, that's a different problem altogether. X, you get an undefined reference to, because me saying extern int X means that it should have another object file with X in it that it can reference and link to, right? The undefined reference to foo, same thing. I have a forward declaration here. It's trying to link to another object file, and it's saying, where's foo? I can't find it. And then likewise, when it comes to our trying to instantiate B, the destructor on A is pure virtual. It can't find the reference. Clang also provides similar output. So either way, you're in the same boat when it comes to your linker errors. Generally, when I'm trying to solve a linker error, it comes down to, what file am I missing? Do I have something that's not included in my make file? If you're using CMake, is it compiling everything that I think it is? Did I add a new C++ or a new header file and not included in the project build file? So I did take this screenshot this morning from Windows because one of the projects I work on uses an external library called RogueWave, and it actually links back against Excel. And so this is a double thing for me. One, this is from Windows Visual Studio. I just copied the one output, and it is small because this is, one missing library. And you'll notice if you can see that top line, it's making a call to CGX map holder, and it's coming from CMApp. So CMApp happens to be my main for the application, but it's trying to access all of these external references, and it can't get to them. And so in this case, if I'm using an external library, the first thing I'm going to probably do is look at my project settings and say, am I pointing to, or do I have the libs that I need inside my project include path? So it's not just about, is it in the project file? It's also about, where are my libs located? I find, honestly, for me at least, when I'm on Windows or Mac, depending on how you set up your libraries, it's a bit easier, right? User local, user lib. But with Windows, with the way some of the libraries get installed, I fought with this error for a while, because it ended up being that there was a particular version that it was looking for, and in order to build one of its consecutive libraries, it had to have a previous library built, etc. In this case, I wasn't able to, copy and paste any of this into a Google to get any sense of it, because it's a private library. But fortunately, I was able to go back to the library maker and be like, hey, what am I doing wrong here? And that was my useful method for that. To learn more about linking, and if you don't understand the linker and you're just getting started in C++, it is definitely something you want to do. Anders gave a great talk of what happens after the compiler at CPPMC 2023. By all means, go watch that. This is one of those videos that I think it's, again, we're trying to build an intuition so that as we're compiling and programming and writing code all day, that when something hits us and something gets us stuck, we're just not stuck as long. Kind of like my squirrel instance at the beginning of the talk, if I get stuck, I kind of have this certain amount of mental energy, and before long I'm getting up and walking away. I don't know about any of you, but I'm like, okay, I just got to walk around the block. If I'm smart, I walk around the block. If I'm not smart, I find myself in front of a cupboard. Snacking is not really the way that's going to solve my code problems. The walks usually help me more. But when you turn around and you get, I like watching talks that are explaining a C++ feature perhaps, but I also like these kinds of talks because it just really gives you the nuts and bolts of, hey, here's what's going on in the background. And then that really helps build on that foundational knowledge, I think, that helps us keep and add to our ability to have and intuit what kind of problems we're having more. All right, so we'll close that up for our link time library, link time and library type issues, and we will work and move on to runtime. So runtime, logical errors, semantic errors. Don't we all love runtime errors? I mean, they're so easy to find. So it's what the compiler doesn't catch, and it's always nicer when the compiler catches stuff and the compiler's like, hey, you might want to look at this right here. You probably did this wrong. But logical errors and semantic errors, they just aren't, that's just not how it goes. That's the one where we really probably made that mistake when we wrote that in. What we intended to write is not, the intended result is not what we're actually getting, right? And so, bad syntax still compiles. I wrote that one this morning. So again, if we look at this one here, you might spot the error. The compiler returns 0. We're not getting our C++ online out. If you don't spot it, once we change to Clang, so let me back up a second here. This was GCC 494. You can see it there over in the bottom right in the compiler window. And when we move to Clang 17, Clang gives us a lot better output. And Clang actually tells us, hey, you got a for loop with an empty body because there's a semicolon there. This is definitely a mistake that I made when I first started out. Without a doubt, putting a semicolon in the wrong spot and my whole code block underneath is getting ignored, but it's actually valid code because it's just, it's a cout statement in a block. So, but we also have, other ways that we generate semantic errors. So this is a little bit bigger example. So we have this product, which is simply going to take a vector of numbers and generate the product for us. So it's going to take, a vector events. It's going to return an int, and reasonably straightforward, I think. So it should multiply 1, 2, 3, 4, and 5 together. But when we run it, the program compiles fine, runs fine, but it returns a product of 0. Okay. And so why is it? Well, again, it's just one of those things where we have syntactically correct code, but we have an error in it. And again, these are the hardest ones for us to try to catch, right? Because the code's correct, and the compiler doesn't tell us anything. We don't have too many ways to get help unless you turn around and use a more modern compiler, as we've been talking about all along, and suddenly, hey, your product variable is uninitialized. And so, of course, when we're turning around and running this multiplication, we're multiplying by 0, which is, of course, or an uninitialized value. In this case, it defaulted to 0. And so this is what we end up getting. So again, use all of your compiler options, use a modern compiler. It'll help you out a lot more. And if you can't use a modern compiler for whatever project you're working on, I do love Compiler Explorer for being able to make, examples like this, where I can take at least a small chunk of code, paste it in there, throw it under a compiler and be like, hey, what am I missing in this particular code? So, another option, if you can't actually compile on the system you're on, and you're allowed to paste the code in and see what Compiler Explorer puts out. So another runtime error, we had semantic and logic errors, and then we have another runtime error, which I know I did this one several times. I finally beat this one, I think, but if you're looking at this code here, the program returns 32,675. And why? Well, because we have an array of 3 items, and of course, C++, zero referenced, as well as other languages. But I've worked on languages that are not zero reference, zero starting point, and so we're accessing one off the end of the array. And in some cases, this will actually cause other types of weird behavior and exceptions and undefined behavior because you're accessing past the end of the array. But in this case, this is what we got. But again here, if you look, this is GCC 464, and we just get this invalid number, an incorrect number. But if we then turn around and use a more modern compiler, there we go. It's telling us, hey, you're accessing something that is past the end of the array. You need to fix that. So those are our runtime errors, right? And that's pretty much our 3 types of problems. And those are the ways that we can go through and work with them. But when it comes to runtime errors, there is more that you can do. And I have to say that, here you can catch 2 of your runtime errors. Yeah, I'm playing on that pun. These are actually catch 2 test cases. So I work in credit cards, and so this is actually a couple unit tests that I've been playing with for making binary coded decimal tests. Now, if you don't know what binary coded decimal is, that's okay. You're lucky you. So binary coded decimal, if you look there on line 58, we have the number 99, which should take 2 bytes. Generally speaking, if you took it as characters, it would be 2 separate bytes. But binary coded decimal is a mechanism that was, I would have to go back and look up how old it is. But what we end up doing is if you split that byte into 2 nibbles, so 1001, 1001 is actually the lower bound and the upper bound of a single byte. And thereby we can actually store 2 decimal digits in a single byte. And this is something that is actually part of the original credit card standards, the ISO standards. And it's used a lot because you're passing a lot of numbers in a credit card transaction. This helps you compress it down in half and makes it a more efficient transfer. There's probably a lot better ways now, but when you have a credit card terminal that is still from the 1980s dialing up on a modem, you get binary coded decimal. But the bigger point here is that you can use test cases to be able to try and when you make something and it's working, you write a test case for it. And this way, when you go through and change your code, you run your tests, you look for your coverage, and you see what your output is. If any of the new codes you added broke something, then you're going to know right away. And that's why test cases are invaluable. Now, I was not a test-driven development person until 2018 when I was lucky enough to take Phil Nash's class at cpppcon. I had only gotten 1 day of his class, and I was sold after that. He does such an excellent job at teaching test-driven development. If you ever get the chance to take his class, don't hesitate. You want to sign up for it. If you can't take the class or if he doesn't have one near you, then by all means, if you want to get a sense of what this is, you want to check out Phil's talk, Rewiring Your Brain with Test-Driven Thinking, that he gave at Meeting C++. Love the talk, and he's selling me on not using PowerPoint anymore. You will see his presentation is beautifully done. By all means, please go watch that and take Phil's class whenever you see it available if you want to learn test-driven development. So building our intuition further, right? So we've looked at some tools. We, mainly with the compiler and errors and such with the base tools we have. But I didn't really touch that much on analyzers. And they're important. SonarLint and ClangTidy are the 2 that I show here, or ClangD, as I mentioned, because ClangTidy, when I first started using ClangTidy, it was, you would run it against your code and then it would give you an output of items. But with ClangD in Visual Studio Code, it literally shows up right in your window right here as you're coding. here's the problems that you have. And so really interactive, love working with it. But my point here is I'm actually showing Sonar Lint right next to Clang Tidy for a reason. And that is because though there is some overlap, you actually have stuff that is in one but not the other. And again, if we're especially new to coding and you're trying to build some intuition about what's going wrong, to me, this is invaluable. And I'm not going to lie, I kind of like that fact of, okay, I don't think I'm a star chart person, but I like the fact that I can sit there and I will go find the remove commented code on line 74, column 3, remove that, and that line's going to disappear. And I'm just like, yes, okay, at least that's done. But the other benefit to it is that you actually, when I see things like this come up, and it turns around and points to like the core guidelines, pro bounds, array to pointer decay, you know, some of the stuff, the pointer decay stuff, I have a few things that I've looked at that way that are, some of it doesn't apply to your code. I mean, that's plain and simple. Some of it is you're written that code that way, and that's fine, and that's what you want. And you can configure these, right? You can turn the noise up and down. You can disable certain rules. All of that is easily available. But either way, if you aren't using linters, use them. They're there to help you. And to me, the benefits are immeasurable. So our compilers matter. As I said, Clang has generally always done an excellent job at reporting. And everyone that I've talked to that's used Clang or worked with Clang, that is the consistent part that I hear. You want to use the newest compiler you can, okay? And if you can't, then use two. If you're stuck on an old GCC, see if you can use an old Clang. Not that you're going to put something in production with it, but just to be able to get the tooling output and see what's going on. On your older compilers, if you're working with particular standards, you're trying to upgrade to certain standards of C++, make sure you're passing it in, make sure you're setting them. This way, the compiler knows you're being very specific about what you're trying to do. And add your compiler options, WAll, WExtra, pedantic. Check out the article from Jason. So Microsoft Visual Studio and Windows has some different options. I've listed them here. I did find it interesting where they're saying, WAll on Microsoft Visual Studio can also include warnings from the standard library. So, it's not just going to get you warnings on your code. It's going to go down into the standard library. And so that's that point where sometimes the options you use, I'm more to one that I'm going to turn all the options on first. But none of us want a wall of noise, just like we don't like template errors that way. But you tune it up and down, just like controlling a volume, right? You want to turn around and set it to what is going to get you the most efficient information you need for the problem you're solving. And to that end, too, like perhaps you run it with a little bit lower noise for a few, but when you're in a problem and you can't seem to find the answer, crank everything up. Maybe it'll give you a tidbit that helps get you into the right spot. So when the problem persists, I like this quote from Albert Einstein. It's not that I'm so smart, it's just that I stay with problems longer. And I think that could probably apply to most of us as developers. If you're lucky enough, you actually have another coder next to you that can, you can be like, hey, can you look at this? Or, but I've actually been in jobs and positions where, I had to make a contrived example to try to get help. And then even when I got help on that contrived example, it still didn't match what I was experiencing for the app I was working on. But persistence, right? And so, I come back to my error that I had with my Python. And again, I just thought this was kind of, I was talking to Phil Nash and I'm like, this is just kind of relevant that I was working on this because it gave me that feeling of being new again and reminded me, because when this error first came up, I totally skipped the top. I didn't even look at it. I was looking at all those lines going, WSGI app, full dispatch request, self. I really do like Python, but the self part took me a bit to get used to. But then I'm like, oh, wait, integrity error, insert order. Okay, I use SQL enough. I got a problem where basically I have a one-to-one relation with a unique column. Okay, I need to make an upsert. Problem solved. But I learned a lot along the way because I definitely went through all those browser windows trying to find stuff. And that's not bad because that's the kind of stuff that, again, those are those little bits of experience that you struggle through that end up getting you that extra bit of knowledge that in the end does exactly what we want, which is using our tools to help build our intuition. So one more shout out for Jason Turner here. This is the link to his CPP Weekly show. If you, I've had plenty of times where there's something I'm trying to figure out, and Jason just does a great job uh, showing examples, walking through them. They are not long, they're nice and concise, and just an excellent job. Likewise, Jason's talks, if you ever chance to see him in person, very interactive talks. You will be in there answering questions and working through it. So definitely check out his show. So build your intuition, use every resource you can, and thank you very much for joining me on my talk. If you'd like to connect, by all means, hit me up. My details are there. For any of you that don't know, I do a lot of volunteering for the community. As you can see there, volunteer liaison, speaker liaison now, CPPCon. So if there's anything I can do with any of the conferences listed, if you want more information, I'd love to hear from you. And thank you very much.